In this screencast, I discuss repeated games. Repeated games are games that are played over and over. In such games, players have opportunities to establish a reputation of cooperation, which encourages other players in the game to do the same, that is, to be cooperative. Such a strategy depends on whether the game is played a fixed number of times or whether it is played indefinitely. Let's do a simple example. Suppose a game is played 5 times, and let's consider the last round. What would be the likely outcome? Well, in the last period, it is likely that players will defect in that game, and that is, do what's best for themselves, not necessarily the group, which is what the cooperative outcome would be. What about round 4? Well, the same conclusion emerges. Might as well defect when you know that the players in the game will defect in the future. So, if you know the game is only going to play a certain number of times, it's very difficult to get cooperation. However, what if the game is played an indefinite number of periods? That is, either it's played infinitely or you don't know when the end is. Then, in this case, one can influence the opponent's behavior by playing what's called a tit-for-tat strategy, sort of you do one thing, then I do that as well. And if you cooperate, then I cooperate. If you defect, then I defect. And so the prospect of cooperative behavior in the future may be enough to induce cooperative behavior today in such a game. So, as I said a moment ago, if you imagine round 1, everybody cooperates, everybody's happy. And then in round 2, you would cooperate if your opponent cooperated. However, if your opponent defected, then you would defect, and you would just continue playing this tit-for-tat strategy throughout the game. So tit-for-tat strategies are useful in the sense that they provide an immediate punishment for bad behavior and forgiveness for good behavior. And this incentivizes cooperative behavior within a game. In this screencast, I discuss producer welfare. Economists and policymakers are often interested in how shocks to market outcomes affect the well-being of producers. So, effectively, what we're trying to do is measure the benefit that a producer gets from selling a good at a price that exceeds the cost of producing that good. So we can define this rather loosely, that the benefit is equal to the price minus the cost. So if the price is equal to the cost of producing a unit, the producer is indifferent between selling and not selling. If the price is greater than the cost of producing that unit, the producer sells. If the price is less than the cost, the producer would not sell. So in this context, cost measures the marginal willingness to sell. Thus, we need a measure for cost. Well, it turns out that the inverse supply function gives us what we need to measure that marginal willingness to sell. And that marginal willingness to sell is actually what we call marginal cost. So the marginal cost represents the minimum price a producer would accept for an extra unit of the good. Thus, the information that's provided by the supply curve can be used to measure producer welfare in dollars, and we call this producer surplus.